In Lesson 5.5, Day 2, you will solve and graph absolute value inequalities that have the greater than symbol, or greater than or equal to. Absolute value inequalities with the greater than sign means that, for example, the absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. So this time we're looking at a graph that looks like this, where it's all the numbers that are more than a certain amount away from a certain number. In this case, these are all the numbers that are at least, or I should say, more than 3 units away from 0. So it's at 3 and to the right, and then to the left of negative 3. Since the graph looks like this is going to be a compound inequality where it is the word or in between our two inequalities in the solution. So for example, solve the absolute value of 3n plus 6 is greater than or equal to 12. We have to first look at case 1, where we have the positive value of what's inside the absolute value symbols. So 3n plus 6 is greater than or equal to 12. That's our first case. And then our second case would be where this is the negative, or the opposite of 3n plus 6 is greater than or equal to 12. Because either way, if this is positive or negative, when you take the absolute value, it's going to be positive. So now let's go ahead and solve our first case. Subtract 6 from both sides. And we have 3n is greater than or equal to 6. Divide both sides by 3. And we get n is greater than or equal to 2. So if we want to look at the numbers that are greater than or equal to 2, we'd fill in the circle on the 2, and it goes to the right. Now for our second half, case 2, we would multiply both sides by negative 1, which would make this positive 3n plus 6. And since we multiplied by a negative, we flip the symbol around. And this 12, if we multiplied that by a negative 1, we'd get negative 12. Now subtract 6 from both sides. (3n) is less than or equal to negative 18. Divide both sides by 3. And you get n is less than or equal to negative 6. These two inequalities are going to be joined by the word or. So we want the numbers greater than negative 2 or the numbers less than or equal to negative 6. So I'm going to go ahead and put a filled in circle on negative 6 for my second inequality. I want the ones less than that. And since this is an OR type, it's the union of the two inequalities. If I laid this graph on top of this one, I want everything that's seen or overlapped, or everything that's covered by the graph. So it's going to look like this. You may want to pause the video and try the next one on your own. Case 1, we're going to work out the non-negative case. 2k plus 1 is greater than 7. And case 2 is going to be the negative case, where this stuff inside of here is going to have a negative in front of it. So if we go back to case 1, you would solve that by subtracting 1 from both sides. 2k is greater than 6. Divide both sides by 2. K is greater than 3. The second case, we'd multiply both sides by -1, which would make this positive 2k plus 1. And since we multiplied by a -1, we'd flip the inequality symbol and the 7 would become negative. Now subtract 1 from both sides. 2k is less than -8. Divide both sides by 2. K is less than -4. We're going to join these two inequalities with the word or, because all of the absolute values where it's greater than a number away from 0, it's going to be with the word or. So now let's go back and graph the first one. K is greater than 3 means I'm going to have an open circle on 3, and the graph goes to the right. And then for the second inequality, open circle on -4, and we want the ones less than, so it goes to the left. Now the union of these two graphs is putting them together on the same number line. Open circle on the -4, open circle on the 3, and it would look like that. So the numbers that would make this inequality true would be the numbers greater than 3 or the numbers less than -4. Our last one is a little bit of a trick. If you take the absolute value of something, it's always going to be positive, and a positive number is always going to be greater than or equal to a negative number. So it doesn't matter what we plug in, this one, it's going to work out. So the solution is all real numbers. I can tell that just by looking at it because I know I'm going to get a positive number on this side, and a positive is always going to be greater than a negative. However, we can work it out so you can see that. Case 1 would be the positive case. R minus 6 is greater than or equal to -5. Case 2 would be the negative case. So negative R minus 6 is greater than or equal to -5. Now if you go and solve this one, you would add 6 to both sides. R is greater than or equal to 1. And then this one, we'd multiply both sides by -1, and you would get R minus 6. You'd flip the inequality around since you multiplied by a negative, and the -5 would become a +5. Then you would add 6 to both sides. R is less than or equal to 11. And we want the word or in between these. Now if we went and graphed the first one, the numbers that are greater than or equal to 1 is a filled in circle on the 1 with an arrow to the right. Now the numbers that are less than or equal to 11 are going to have a filled in circle on the 11, and they're going to go this way. And the union of these two graphs, if I laid the two graphs on top of each other, everything that's covered up by the graph is going to end up being the entire number line. So rather than saying the solution is the numbers greater than or equal to 1 or the numbers less than or equal to 11, we can say the solution is all real numbers.